The extract class refactoring moves variables and methods from one class into a new class. This cleans up the original class by taking related code and putting it in its own class. Each class then focuses on its own job better. Extract class separates what a class does into different classes. This makes the code easier to understand, and it's a common way to improve code quality. When used right, extract class helps manage complexity and separate responsibilities in a project. Hello guys, welcome again. To start, let's understand what extract class is all about. As code becomes larger and more complex, classes sometimes do too many things. They get big and hard to follow. Extract class helps with this. It looks at the class and finds code that works together for one specific purpose. It then takes that code and moves it to its own new class. This splits up the responsibilities, so each class has a cleaner job. It makes the code easier to read, change, and maintain over time. And by separating concerns, extract class improves class structure within a codebase. Okay. This technique falls under the code moving category in our refactoring diagram. It's important to know that when we extract code into a new class, it only focuses on doing one job. This is an important coding rule called the single responsibility principle. It's part of a set of best practices called the solid principles. These principles help us write code that is easy to understand, change, and reuse. Okay, let's give you an example to show how extract class works in action. Alright, imagine we have a class called order. Right now, it does two things. It keeps track of projects added to an order, and it handles things like calculating totals and scheduling delivery. These two jobs, managing projects and processing the order, are mixed together in one class. That makes the code harder to understand. We can use the extract class technique here to split them apart. First, we'll create a new class called order processor. This class will contain just the code for processing orders, like calculating totals and scheduling delivery. By taking that code out of the original order class, we'll leave the order to focus only on managing the product list. This separates the two responsibilities into their own classes. It makes the code clearer what each part is doing. Next, we'll create a new private field inside the order class. This field will store an object of the order processor class. Additionally, we'll make sure to set up the order processor object when we create a new instance of the order class in its constructor. This connects the two classes, so order still has access to do processing tasks. But now those tasks will happen through the separate order processor class rather than being mixed in with order itself. By doing this, we can update process order method and delegate it to the processor. Now the two jobs are split cleanly between classes. The order class just cares about the product list, and the order processor class only deals with processing tasks like calculating totals. This makes the code easier to understand, since each class has a clear job. It will also be more durable. We can change one class without affecting the other as much. and it's easier to add new features since new processing logic would simply go in order processor rather than changing order. Okay, done. See you soon.